Hey, welcome back to our channel. And this time we have brought to you a special topic that is the Class D amplifier, the Class D power amplifier or Class D audio amplifier. So nowadays, in a very high fidelity stereo system at our homes, we can open up the stereo system, and then in that we can find this module, which is a Class D amplifier. So this is how it is constructed. This is the PC board that looks like. So in this module, we are going to see the basic working principle of Class D amplifier, how it works, its pros and cons, and its comparison with the previous classes of all the amplifiers. So we have seen Class A, we have seen Class B, we have seen Class AB, we have also seen Class C amplifier, and the final category, I would not say very final, but it is one of the most advanced category, is the Class D. And nowadays in digital integrated circuit or mixed mode integrated circuit, you basically have this integrated IC for this class of amplifier. So in the market, when you go for designing the stereo system, the hardware for it, you basically require an IC which inside it is a Class D amplifier. So let us see, this is a block diagram of the Class D amplifier. So it consists of primarily three stages: between your input and between your output. So input is your audio signal frequency ranging from 20 hertz to 20 kilohertz. That's the frequency range of the signals which needs to be amplified and delivered to this load, which is your loudspeaker. Okay, and typically you need, over this frequency range, you need a gain of over 40 decibel. You need, let me draw it here. Here is the frequency response of a typical audio amplifier. So you can design your amplifier so that your gain right over here over the frequency range is constant, and this range is from, let's say, 20 hertz to 20 kilohertz, and this gain value has to be approximately, let's say, 40 dB, with minimum and the lowest possible distortion and the lowest possible power consumption. So Class D is well known for its the lowest possible power consumption capability. And why that power consumption is extremely low, we are going to see. And because the power consumption is going to be extremely low, the efficiency of this class of amplifier is very high, high amongst all classes of the amplifier. So if you are new to this module, we encourage you to refer back to our previous module and on all the classes of the amplifier. So the first point, Class D amplifier has the lowest power dissipation among all classes. Therefore, highest efficiency up to 80% or 90% is possible to attain. So what is the efficiency? So efficiency we have defined, it is expressed in percentage. It is eta, defined by eta, expressed in percentage, given by the AC power output delivered to this load. This is the load, divided by the DC input power, that is the power dissipated during the delivery of this load, PAC, power to the load, multiplied by 100. So in Class D, this efficiency up to 90% is possible. In Class A, on the other hand, which is also a high fidelity audio power amplifier, it can give a good quality audio output. However, the power dissipation is extremely high. Why? Because if you recall, we use the single transistor output stage in the power amplifier using class A, where we provide a DC bias to the amplifier, let's say through the resistor, and here is your power supply, and there is a constant current being drawn by this transistor when you switch on the DC power. So even if you don't apply an audio input to the circuit without amplification, as soon as you switch on this DC power, you have amplified output only when you apply the input. But even if your input is zero, because the power supply is on, you have a constant current being consumed, and it generates also a lot of heat, and that's gives rise to a lot of power dissipation into the circuit. And obviously, when you apply the input, you have a amplified power amplified output. But the efficiency is limited up to 30% maximum. So we solve this issue by means of class B and class AB and class C. So we have covered all those topics in earlier modules. So if you are new to this module, we encourage you to refer back to those. So now we got this first point covered. So why in class D we have a lowest power dissipation? Because the output stage, here we use the switching controller and the output stage in the class D amplifier. So the output stage is consisting of two MOSFETs or two JFETs, N channel and the P channel. Of course, they are complementary MOSFETs, and this guy receives the logic 1 and this guy receives the logic 0. So it's a kind of switching circuit, and only when they switch to transfer the power from input side to the output side, there is a current flow through these transistors. There is a current flow through this transistor. And when they do not switch, there is essentially no current. So obviously power is equal to voltage times current. If the current is zero, the power is zero. That's why you save a lot of power due to switching option, switching activity. And that's the basic reason for class D amplifier having such a lowest power dissipation. And therefore, since you have essentially negligible DC power and you have a high power output, so efficiency up to 90% is possible. So output stage, we've seen that it consists of switching transistor. They produce these square wave output. So it's a kind of switching circuit or a digital circuit. So what you do basically, you use audio amplifier signal is here. So that's for example, sinusoidal waveform. First stage is your modulator. This is your modulator. So modulator's job is to receive two inputs at its pins. One is the audio input, and second is a reference generators such as triangular wave. And then there is a mixer inside. So the internal construction of the modulator is such a way that it produces or converts the audio input into a short series of pulses at its output, which becomes an input to the switching regulator, a switching controller, excuse me, and the output stage. So now the purpose of this stage is to take this signal as an input and produce a power output in the same form. So square wave input, the square wave output, but the output is a power wave output. Okay, so square wave as a power wave output here. And then, as I said, these transistor conducts current only when they switch. And when they switch, they have a lowest possible voltage drop. So here, these are the three terminals: drain, gate, and the source. Drain, gate, and the source. So when you have the transistors on, you have a voltage drop between drain and the source terminal called as VDS. That is the voltage across drain and source. So that VDS is the lowest possible when the transistors are on. So obviously, again, you have power is equal to voltage into the current, and the voltage is VDS and the current is IDS. IDS is the current flowing from drain pin to the source pin of the transistor. So VDS is the low, and therefore the power is low. And that's how you have the lowest power consumption. Okay, so here I have written the transistor have the low VDS when they are conducting current, therefore the product of current into voltage, which is power, is low. And the modulator job we have just explained. But the modulator output, since it is a modulation of low frequency signal with a high frequency reference, you at the output, you have a mix of low frequency content and the high frequency content. So this content also comes at the power amplified output, which is the output of switching controller and the output stage. Therefore, we use a low pass filter consisting of inductor and the capacitor. The job of the low pass filter is to minimize the electromagnetic interference. That is the first point. It also avoids driving the speaker with the high frequency content that is present in the output of the power amplifier output stage. So its job is to filter the high frequency. It is only passing the low pass content, that is the audio signal, which is right here in the amplified waveform that drives your loudspeaker. And obviously, to further reduce the power consumption, the design and the construction of this block has to be also low loss or lossless or nearly low loss. Okay, so that the power dissipation advantage that is coming from this stage is retained. So that's all about the Class D power amplifier. This is a typical example, and power amplifier output are available depending on the amplifier, whether you need it in your home stereo systems or in your headphones. That is the small requirement of power. In theaters and in the cinema halls, you have a large auditorium theaters where you require huge power, tens of watts. Here, the power requirement is about milliwatts. In the headphones, you have a power requirements about microwatts. So that's how you basically can choose the classes of the amplifier. But basically, you go for class D amplifier. Accordingly, you optimize the design. So if you like this video, click the like button, put some comments, what you think, and as your opinion, and share it with others for a wider reach. Till then, wish you happy learning. Stay tuned for more engaging content like this.